like the most of my videos, also this one, it's by 90% for the customer, 10% for whoever understand what I'm doing here and from which car it is. I'm not gonna be in details. Alright, this is, like I said, for the customer. Today it's Thursday, June 23rd, 22, obviously. Let me connect one second one of these thermostats. One, I took it apart. I have another two over there. Just it's important to be on the video to understand. Alright, power supply, switch is on. Power supply is on. Let's give electricity, 14 volts. Alright, I have connected this thermostat. Now, this thermostat in the middle has this element that this is like a resistance, whatever, this warming up when you give electricity to this. And it's located here inside. Nothing new here, okay, it looks like that. So when it's getting an order from the ECU and comes hot, you're gonna see that this piston, this sleeve, it's gonna start moving. Meanwhile, while we're waiting to warm up, let me show you something. I'm talking about this one. Alright, now when it's it finds its place. So when it's at this position, that means when the engine is cold or it's not working, if you like, or while it's warming up, it's located at this place. Alright, this is the lower radiator hose, this is the upper radiator hose. When this expanding, when it's warming up and it's expanding the sleeve, this moves down there. But when it moves down there, to don't have crazy difference on the temperature, to don't have fluctuations, especially in a cold country, now it's lifting up, now it's coming up. Let's see this, sorry. Alright. This piston, it seals here. When this comes up, it's opening the coolant path for the upper radiator hose to start using the radiator and to don't recirculate the coolant inside of the engine. Alright, and it's almost full compressed spring. Alright, that's the path from where it's passing the coolant, and you can see that it cannot open more because there is no room. I mean, it's been fully compressed the spring. Let me turn off the electricity because no need too much. Alright, so that's the coolant path from where it comes. Alright, if you put the sleeve inside, it looks like this, and then the plastic, this one, it's ending up there and has this coolant path. By the way, to come here, there is a cut from this side till this side, not all 360. You see that 90 degrees, it's not been cutted. Alright, then you see that this lip, it's on the way. This plastic piece, if I enter it inside, I have already moved there, it comes, that's the path. You see that this plastic piece, it's entering a little bit inside. It comes, let us say, somewhere there. Okay, then what's happening? There are these two notches here and here, that this one, it's the recirculation inside of the engine. So the coolant, you're gonna find the easiest way to recirculate. If you have these two escapes from here, it will gonna have a rate that it will gonna bypass the radiator. That means the coolant that's looping here, it will not gonna pass through the radiator. Okay, you have a suction from this side sucking the pump, from this side it's pushing out to use the radiator, so it's gonna recirculate inside. What's the target? To have the minimum recirculation and to have one small hole as a bleeder, that this will gonna be at 12 o'clock. That means when they will gonna enter the other sleeve that they were gonna fix, you see that has plenty of space here around. It's just now closed. I hear the spring, this hot, be careful. So you're gonna be at 12 o'clock one small hole for a bleeding purpose, to remove the air from there, because if it's sealing 100% it won't. gonna remove the air. You're gonna have always an air pocket here. So you're gonna come inside, you're gonna seal on this O-ring, and you're gonna seal also here inside, in these two spots. You're gonna tell me why you're doing that. It's not for performance, it's because the car, from factory, bone stock, less than 10,000 kilometers, it's overheating. You're just cruising around, and it's overheating. And it comes back to the same thing what I was saying, that how is it possible, the same car that you're gonna be, let us say, for Canada or for Alaska, to sell the same car without any difference in Middle East? I mean, it doesn't make any sense to me to work the same car with the same radiators, the same everything, to plus 50 and to minus 40, example. All right, and that's why I'm doing all this. This is not, it's request from the customer. It's not from me. He said that, you know what, I have to stop with the car. I have to leave it to cool down to be able to continue. And this brings me here that I'm making the prototype. I'm on the lathe and I'm start machining the prototype, one for testing and one to make in mass production. Okay, then there is another one pipe that it's looping the coolant and it's not using the radiator and need to be modified. That means by modifying, let us say, the thermostat, it will gonna help, but it's not gonna be 100%, it's gonna be by 60%. There is another 40% from some coolant pipes that I saw on the radiator hose. So I'm gonna fix this for now, and when it comes the car to make the test, because always we are logging with the computer, with the diagnostic, we're not doing something just by luck or by guessing, all right? We need to make sure that we're gonna be okay, and to see what kind of effect we're gonna have, let us say, at the winter here, that there is no winter at the end of the day, but we have to check all these things. Again, this is what I'm doing, like I said also for the Mercedes, like I said for the Volkswagen Audi that I have done this before. It's not for a cold country. It's for a hot country that the engine is suffering. And when it's keeping, let us say, 105 to 110 degrees coolant temperature and oil temperature, these they're doing mostly for the emissions, for the fuel efficiency and for the emissions. But in this case, especially in this case, the car is suffering and it's overheating and says to you on the instrument cluster, it's popping up a message, engine overheat, and then you have to stop the car. By just cruising with air condition on, literally. Okay, we try before, we change the thermostat, we put a brand new thermostat, we change the water pump, we fix all the seals again, we put all the new seals, the guys outside, not me. I saw them what to do actually, to be on the same page. All right, again, it didn't solve it. We was making bleeding again and again and again, original coolant, not something different, what they're suggesting from the factory. Again, I don't want to mention which car it is, some people will understand, all right? And again, like I said earlier, it's for the customer, to show him what I'm doing, what I'm planning to do. That's it for now, we're gonna see later on. I have to remove some material, all right? Now, like I said, the original one, it leaves these two pieces, all right, two notches here that you see from here, it can pass a coolant. This is for bleeding first, to don't have an air pocket here, and to make small adjustments on the temperatures, to don't have sudden adjustment. Now with this one, yeah, it has a little bit more tight fit. This goes there, and then it's blocking completely this path. That's why I need to make one small hole, 1.5 to 2 millimeters at 12 o'clock, just to bleed the system, to don't create an air pocket here inside. I hope that makes sense what I'm saying. If you don't understand, no worries, don't watch the video. And I have to remove a little bit of material from this, it's too thick here, no need. Now, I need to fix a sender that will gonna come here, and then we're gonna support this one with one small spring to stay in place all the time. And this is how it looks like. Yeah, it looks a little bit like a shed, I know that, but it will gonna work. This is to make a test, to get some readings, to see, let us say, how it's reacting the car, if he likes it, the temperatures and this kind of stuff, if everything is fine. So Once again, it comes there. All right. There is a space here, obviously. All right. And then it comes this, place there, and it's closing here and looks like this. I need to open one hole. Yes, that's what I didn't do up to now. I need to open one hole at 12 o'clock. So here up, like I said, to be everybody happy, to come the air out. Now the second one that we're gonna fix, I'm not gonna continue the video, I'm gonna stop here. The second one that we're gonna fix, I'm gonna make it a little bit better than this, to be a bit, it's the same dimensions. I might keep 1 millimeter here and here, and then I'm gonna let the welders weld it here, and then I'm gonna machine it again to be true. I'm gonna leave half millimeter, let us see, half millimeter here, to make it again straight. Okay, and this one I need to leave it another 1 millimeter extra from this side. It's gonna be much better, I guess. So that's it. You aren't gonna see any data. The customer here gonna see the data from the car, from the diagnostic. So that's why I'm saying that it doesn't make any sense to watch the video if you don't know for which car, and if you don't see how it's gonna end up, if it's nice or not, it doesn't make any sense to waste your time. So that's it with the bypass. So from this we end up to this. This looks like see how nice and true it's turning. It doesn't matter. This is, like I said, this is for demo, for testing it, and this it's not precise. You can even remove that, like I said. Then you have to put back again inside. You don't have an open circuit. There you go. Nice. Nice. All right. The height, yeah, it's supposed to be, yeah, because it's centering inside and comes up to there, and you don't have the lip anymore to bothering from here. Alright, and yes, there is no lip or something here. That's the reason on the next one I want to leave 2 millimeters more here, because you can see the seal here. It's not the ideal. The next one, it's not a big deal. That's it. Thank you very much. Have a nice weekend. Friday today, right? Or Thursday? What's the... no, Thursday. Okay. Alright. Yep. Thank you.